So again, symmetry, odd functions or even functions. The odd is symmetric with respect to the origin, has nothing to do with odd numbers, and even has nothing to do with even numbers. We call a function even if the graph is symmetric with respect to the y-axis. So 33. In 33 on page 252, is it odd, even, or none of the above?
Would it be even?
Yes, of course, it's symmetric with respect to the y-axis. Excellent. Thank you very much. So the graph in 33, even. And this is on page 252. Perfect. 34. Can anyone tell us whether the graph in 34 is even, odd, or none of the above?
Odd.
Exactly. The graph is perfectly symmetric with respect to the origin. Excellent. Let's look at 35. It doesn't have to be the first quadrant and the third quadrant. It can be the second and the fourth, as long as the graph is symmetric with respect to the origin. So 35, odd, even, or none of the above?
None of the above.
Even cannot be because it's not, even would have been this way, symmetric with respect to the y-axis. What we see in the second quadrant is identical with what we see in the fourth. Up. Okay, so odd function in 33. Symmetric with respect to the origin. Final one in 36. Odd, even, or definitely none of the above?
Neither.
Of course, not symmetric. It's not symmetric with respect to the y-axis, and it's not symmetric with respect to the origin. Excellent. Perfect. Now, how do I determine? It was easy. If I'm given the graph, it was easy to identify if it's odd, even, or none of the above. But what if I'm not? What happens if I'm given the equation? How do I determine whether the function or the relation or whatever I'm giving, it's odd, even, or none of the above? Okay? The same thing with functions. So I need to explain. There is a relationship. So for odd, let me graph an odd function and take it from there. I want you to understand the relationship because I know it's easy to memorize it, but I want you to understand it. So here's an example of an odd function. This is indeed an odd function. I'm going to choose a point here. And I'm going to say this is x. And of course, this must be f of x, as we know. So this is f of x, the graph of f of x, and x, the origin, and y. Symmetric on the other side, if this point, let's say, is 2, 3, what should this point, as an example? It's not, I'm just giving an example. If this point, let's say, is 2, 3, can anyone tell us what this point should be if the function is indeed symmetric with respect to the origin? I cannot say 6, or negative 6, negative 4. It's not going to happen. That's not the case. So if this distance equals this distance, my graph is not perfect. So if this distance equals this distance, and assuming that this point is 2, 3, I know for sure what are the coordinates of this point. This is one application of symmetry. So if you ask me to graph this, and I know it's symmetric with respect to the origin, I only have to graph this piece, and then I will copy it here, and I'm done. So sorry, I know I talked too much. So if this is 2 comma 3, what should this one be? Carved in stone for sure.
-2 and -3.
Oh, of course. Exactly. It has to be exactly the opposite. So if this is x and f of x, obviously this must be negative x, exactly as you told me. If this is 2, this has to be negative 2. If this is 3, then this has to be negative 3. So then this is the opposite of f of x. So 2 comma 3, negative 2 comma negative 3. So this is also the same thing with f of this value. So in x, I have x, I plug in to find f of x. If I have negative x, I plug in to find f of negative x. This is the relationship for odd functions. The function value, the function evaluated at negative x has to be identical with the opposite of the function value at x. So if you're giving me, let me illustrate this and then we'll talk about it. So let's say you give me 38 and you ask me, is 30, oh, I didn't copy it. Brilliant. It was x cubed minus x. Yes, it was. So if I have f of x equals x cubed minus x, and you ask me, listen, is this function odd? This is what I'm going to do. I'm going to find f of negative x. F of negative x. Then first step first, I look at this and I say, oh, that's easy. The pattern is the following. Whatever to the third minus whatever. Okay, so my whatever is negative x. Fine, no problem. So negative x to the third is negative x times negative x times negative x, which is a negative number, a negative sign, x to the third. The opposite of negative x is positive x. So I determine this piece. But now I have to determine this piece. If they are equal, then I'll say, yes, it's odd. If these two pieces are not equal, then I'll say, no, it's not odd. So I determine this piece, and now I want to determine negative f of x. No problem. All I have to do is multiply both sides by negative 1. So negative f of x is this times negative 1. It's this times negative 1. If these two quantities are equal, I will say the function is odd. If these two quantities are not equal, I'm going to say the function is not odd. So what is our conclusion for this example?
It's odd.
Yes, the function is odd. Of course, I chose one that is odd so I can illustrate. So for odd functions, f evaluated at the negative x equals the opposite of f of x. This is carved in stone. This is the definition or the algebraic explanation for odd functions. Of course, we have something similar for even functions. Let's look at one more. So let's say 40. in 40, I have x squared minus x. So this is number 40. And for now, I'm just going to ask myself, is this function odd? I have to find two things. I have to find f of negative x, and I have to find the opposite of f of x. If this equals this, I'll say yes. If this doesn't equal this, I'm going to say no. So I plug in negative x squared. Negative x with minus in front is positive x. Remember, negative x squared is a positive x squared plus x. I multiply both sides here by negative 1. So this is negative x squared plus x. If this is identical with this, I will say the function is odd. If this is not identical with this, I will say the function is not odd. What do we conclude?
Not odd.
Not odd. This does not equal f of negative x, does not equal negative f of x. These are not the same, not the same. It's not odd. So now I need to discover the same relationship for even. Let's discover it together because it will be easier to remember. So I'm going to graph an even function. This is an even function, perfectly symmetric with respect to the y-axis. Of course, in the same way, I'm going to choose a point here, which is, of course, xf of x. And if let's assume that this is 2, 4, on the other side exactly, what should this point be? If this one is 2, 4, what should this one be?
-2 and -4. Sorry.
So, but it's at the same height though. So this is negative x, but it's at the same height. So you're right with -2,
4.
indeed. It's not on the opposite. So it's indeed on the other side. So if this is 2, this is -2, but the height does not change. So this is also f of negative x. Very easy. F of negative x is identical with the function as is. So see how similar this is the same, but here is the opposite, and this is the identical. So this is 4 even functions. Much easier, because I don't have to find the second one. Here I have to find two different quantities. F plugging in negative x and negative f of x. Here I don't. I only have to find this. Is it the same with the function or is not? So the even situation is easier. So I'm going to choose an example, and then you can choose the one you like. I'm going to choose 41. So the question now, h of x equals x squared minus x to the 4th. If the question is asking me, is this function even? I only have to determine this. Can anyone determine f of negative x for us? Keeping in mind that this is power 2 and this is power 4. What would you say? What is f of negative x? What does it equal to? Remember, it's negative x squared minus negative x to the fourth. So what is this equal to?
X squared plus x4.
But remember, negative x to the fourth power is still positive x to the fourth multiplied by negative 1 in front. The even power is always positive. The even power is always positive. So there is no change. So this is the same with x squared minus x to the fourth because the powers are even. Since these two are equal, f of negative x is identical to the original function. What will you say about h of x? Odd, even, or none of the above? Odd, even, or none of the above? Please, anybody? These two quantities are equal. Oh, sorry. These two quantities are equal.
Even, right? Even.
Yeah, of course, of course. The function is indeed even. I just wanted someone to say so. Do we understand this property of symmetry? A function being odd or even? Yes, no, maybe. Anyone, please say something.
Yes.
Thank you. Now let's choose one problem so we can take it from the beginning till the end. These were just examples that I chose just to make sure that we understand. So let's choose any problem you would like, other than the ones we just looked at, 41, 40, 38. So choose any problem. We are asked to determine whether the function is symmetric.
Can you do 30?
Yes, of course. 30 is not a function. So 37 through 48.
Oh, 47.
47, perfect. Perfect pick. 47, we have f of x equals x times the square root of 1 minus x squared. Perfect. Remember the two relationships. F of negative x equals f of x for even, and f of negative x equals the opposite of f of x for odd. Obviously, my starting point is this. No matter what, if the function is symmetric, I have to find f of negative x. So f of negative x means I plug in negative x here. 1 minus. Can you plug in negative x in here and tell me what you get? The sign in front has nothing to do with anything. Can anyone plug in negative x in x squared and tell us the answer? Negative x and square it. What do we get?
X.
But squared, right? So negative 1 squared. So negative 1 squared is 1, and x squared, and x squared is x squared. So I determined f of negative x. I have the function, which is this. So now I only need to determine negative f of x. So multiply both sides by negative 1, negative f of x equals negative x, the square root of 1 minus x squared. So now I'm asking myself the following question. F of negative x, does it equal f of x? Does it equal negative f of x? Or none of the above? So does, from our calculations, does f of negative x equal f of x? Then I will say even. If f of negative x equals the opposite of f of x, then I will say odd. Only one of these three questions has a yes. The other two are no. That's always the case. And now we have to choose. Is it even? Is it odd? Is it none of the above? Meaning not symmetric.
None of the above.
So,
Yes,
f of
odd.
yes, because these two quantities are equal. Do we see that? F of negative x is identical with the opposite of f of x. Because these two are equal, the function is odd. Not this and not this. And yes. Do we see that? That f of negative x is the same with negative f of x. And this is the property called odd, or the function is called odd function. Is this clear? Do we,
Yes.
do we understand this process?